Great, we'll begin. So, okay, we have passed this extended long weekend. So how are you guys' weekend?
Good.
Pretty good.
Yeah. So anyone has more than one word to say, more than the good to say, some interesting story, some funny things happened? Okay, so first of all, I want to let you guys know I'm a very inclusive person. I try to make this class very relaxed for you guys too, so that you guys will feel more comfortable and feel more efficient in that way. So that's why I often talk something outside, not only outside lecture notes. I often talk something about life. So just make you feel interesting. So yesterday is a Label's Day. And I was preparing to go to another BBQ event at my friend's house. My landlord is also preparing to go to another BBQ event in his friend's house. So we were all packing up our stuff, our gifts, ready to leave. Then we had a short talk. So I don't know he was going to another BBQ event, but he know I'm going to the BBQ event already. So I said, oh, I'm going to the BBQ. He said, oh, what? Oh, I'm also going to that BBQ. I said, excuse me? Are you going to the same BBQ with me? He said, no, I'm going to another BBQ. So this gave me a kind of idea. So many people go to BBQ on the Label's Day. So I would say Label's Day is not Label's Day. It is better to be called as Label's BBQ Day. Okay, just say something funny. Label's BBQ Day. Okay, let's go to class. Okay, so do everybody see the lecture notes to see in the canvas already? So you do or do not see the to see? I see somebody waving.
I didn't see it.
Okay, let me check it again. So I hope I have uploaded, but there is a possibility I forgot to do so.
I don't have anything for week 3 at all.
Or maybe you are right. Maybe you're right. Give me a minute. Let me upload everything there. Okay, now you should be able to see on the week 3 module, see the lecture notes for today. By the way, in the future, If you see I did not upload the lecture notes before class, please feel free to email me. Okay, please feel free to email me to do so, to remind me anything I forget. So now you should be able to see on the week 3's module, the lecture notes is already there. Please go to there and download it. Okay. I give you 30 seconds. I think that's a reasonable time to download it. Okay, have you downloaded the lecture notes? Give me some feedback. Do you need more time to get prepared?
I'm good.
Okay.
I got it.
So let's get started. So let me switch to my document camera. Okay, this section, we are not learning any new knowledge. We just use some kind of mathematical things to solve those real world problems. At the beginning of the section, we are giving you 8 hints for problem solving. So please read through them. The first one is, we may have more than one answer. Okay. Second one is, we may have more than one method. I think those are very intuitive. There are different possibilities for we to do the question. And the third one is kind of vague. Use appropriate tools. So we will see how we can do that in the examples below. Okay. So the first one, consider similar problems. Just add one more sentence. Any complex problems are derived from simple problems. This is a basic fact about our mathematics. Okay. So if you meet a problem you don't know how to solve, search in your memory to see if there is something similar. Hint 5, consider equivalent problems with simpler solutions. I think this is almost identical with hint 4. Hint 6, approximations can be useful. So sometimes you cannot get an exact solution. So you need to get something approximately correct. That will be good enough. Hint 7, try alternative. So if you're stuck in one direction, so try different directions. Hint 8, do not spin your wheels. Okay, so this is just, hint 8 is just kind of joking. Okay, let's see how we can apply those hints in solving those problems. I want to remind you, do not overthink. Do not overthink. Just think every question in the most naive way. Think about what are the possibilities are there. Okay, so suppose you have 40 blue socks, 40 brown socks in a drawer. How many socks must you take from the drawer without looking to be sure to get a pair of the same color. So in one drawer, you have those socks. You can see 40 and 40. Those 7s are not. But what you actually need is just one pair. You just need one pair. Okay. So let's start from the possibility. If you get a blue sock, round 1, you pick up the first pair is first sock is blue. Let's see what are the possibilities for the round 2, okay? Round 2 can be blue, or it can be brown, right? If round 2 you get blue, you get the pair of the same color. Is that correct? So you succeed. So in this case, you only need 2. If you pick a brown one, you get different colors. So you have to go to round 3. You have to pick the third time. The third time, since you get blue already, you also get brown. So whatever color you get, you will get a pair. If you get blue, yeah, that's a pair. If you get brown, that will be another pair with this brown. You get in the round 2. So I write 2 here to remind you that we are finishing the second round. Okay. So whatever happened in the second round, in the first round, we are always doomed to finish in the third round. Right? We can always get a pair of socks in the same color in the third round. So the answer should be 3. However, you guys must notice that I started with blue socks. You can also start with brown socks. Almost everything is repeating the same process. If you get brown, second round you can get blue or brown. If you get brown, then that will end the process of picking up socks. If you get blue, you go to the third round. You either get blue or brown. Then everything still finished at the third round. So the answer is just 3. Okay. Any question about my analysis process? Any question, any doubt? Okay, so let me remind you again, do not overthink. Do not overthink. Just be clear with the possibilities. If you get blue in the first round, what do you get next? What do you get in the third round? Okay. Okay. So example 2. It takes you 30 seconds walk from first ground floor of a building to the third floor of building. How long will it take you to walk from the first floor to the 6th floor at the same pace, assuming all floors have the same height? So to help us solve this problem, we had to draw a picture of the building. This is a ground. This is a building. So this building has 6th floor. Okay. So this is roof 3rd floor, roof of 2nd floor, roof of 6th floor. Okay. So this is 1st floor, 2nd floor, 3rd floor, 4th, 1st floor, 5th floor, 6th floor. Okay, so instead of me solving this problem, I think I can give you, let's say, 3 minutes to think about this. You may be able to solve it without my assistance. Okay. So look at this graph. Think about it. When you're and think it from the common sense way. Okay. You start from here, takes you 30 seconds to come to here. Okay. So how much time does it take you from here to here? Okay, here, not to the roof. To here. Remember your final destination is here. I write a small x here to represent that you should arrive here. Okay, think about it. Meet again very soon. Feel free to ask me any question. Okay, let's come back. So does anyone has any opinion or any ideas to share?
Each floor is 15 seconds.
Okay, great. So then what?
Then it's 75.
Okay, great. Thank you very much. Frank, you get it all done. So let me elaborate what you have just said. So notice that we are starting from the first floor to the third floor. But do not be tricked by the word third floor. The word third floor is just mean you just walk from here to here, which is just 2 floors. Okay, You're not walking to the roof of the third floor. You're just walking to the floor of the third floor. So you're walking 2 floors. 2 floors, you spend 30 seconds. So 1 floor is just 15 seconds, right? That's a reasonable guess. That's a reasonable calculation, correct? So when you start from here to the 6th floor, how many floors do you walk? Notice that from here to here, you actually just walk 5 floors because you are on the roof of the 5th floor, or you are in the bottom of the 6th floor. So you just walk for 5 floors, okay? And we know 1 floor is 15 seconds, takes you that amount of time for you to walk. So 5 floors, 5 times 15 seconds, which equal to 75 seconds. That's it. So anyone has any question on this one? Okay, so let's continue. Feel free to pause me if you have any question, okay? Do not be shy. Okay. So example 3 is a little bit tricky. Okay, imagine this is a friend, Ruben. Ruben is a smart guy or smart girl. She or he often says something wisdom. So one day he told you this. 2 days ago, I was 20 years old. Later next year, I'll be 23 years old. So you heard what she or he said this. You are curious. What? How can this be possible? You start to think. Is this possible? Okay, before I tell you the answers, I also would like you to think, let's say 90 seconds on your own to think whether this is possible or not. Yeah, think about it and feel free to voice your opinions. Okay, anybody want to share any opinion, any idea? How can this be possible?
I'm thinking maybe it has something to do with his birthday
Oh, yeah.
being within last year. So within those 2 days ago,
Oh,
his
very
birthday has passed, and so has the last year.
yes.
I think
Yes.
his
Yes.
birthday had to have been on December 31st.
I'm sorry, can you speak it again?
I
You
think
see-
like if his birthday was on December 31st and 2 days ago he was 20, then the 31st hit, then he turned 21, and then later the next year he turned 23. So yeah, if it's like on the December 31st, I think it is possible.
Okay. So I'm not sure what you said is correct or not, but we can always try it out. Yeah, you would recommend December 31st is his or her birthday. Okay, so when this person said this 2 days ago, I was 20 years old. So if he says that on January 1st, let's say he was born 2000s. Okay, let's say he was born on this date. Okay, and he said such a sentence on the year 2021. January 1st. Okay, so 2 days ago, which is December 30, he was indeed 20 years old, right? So 2 days ago was the year 2020. So Ruben is 20 years old because he has not turned 21 yet. Is that correct?
Yeah.
So this is, assume this is his real birthday. Okay, ignore my January 1st here. So I read this by mistake. Okay. So December 31 is real birthday for Ruben. So 2 days ago, he was 20 years old. So December 31 comes, he turned 21 years old, right? I write YRS to represent years on that day. Let's see what happened later next year. And he can say this 2 days after his birthday. So he can say this on 2021. Ruben said the sentence. So what is later next year? Next year is 2022. Later next year, what is later next year? So we need to find a date in the year 2022, which Ruben turned to be 23 years old. We can try a date which is as late as possible, such as December 31. So if December 31 comes, how old is Ruben? So when it was 2020, December 31, he turned 21 years old. So December 31, 2022, Ruben turned 23 years old. Great success. We found a date which makes things possible. Okay, great. So it is possible, and we found a date which make it work. So anyone has any question or opinions on this? Okay, so you can see there's no calculation here at all. You just use your common sense to think about it, try out all the dates to see whether those claims are matched by those dates. Okay. Any question?
No.
Great. So sounds like we are learning something easy today. Example 4. This question, I also want you to spend, let's say, 5 minutes to work on it. 5 minutes to work on it. So this question needs a little bit of calculation, and it is a little bit more complex than the previous ones. A toll collector on a highway. So this question must be old, since today all the tolls connecting about taken by the camera. You automatically receive a letter from the toll authority. So this is an old question. They still use human being to connect fees. So this person receives $2 for cars, $3 for buses. At the end of 1 hour period, he collects $32. So he's asking himself, how many cars has just passed? How many buses has just passed through the toll booth? Given such information, how many possible combinations between cars and buses? I want to remind you that we do not have fraction for cars. We do not have fraction for buses also. So please try to work, spend 5 minutes to work on it. Feel free to let me if you have any question.
I got it.
Oh my God. Thank you. So if you got it so quick, so let's just be patient and wait everybody to try it, and then we can come together to discuss it. Okay, so let's come back. Okay, so anyone give me some ideas, suggestion how to start on this question? Elizabeth, can you give me your input? Frank, do you have any opinions?
Yeah, so I started off with 10 buses and 1 car. And then because that was like the most buses you could do or put in. So that's $30 for all the buses and then $2 for the car. That makes 32. And then I basically subtracted as many buses I could in which I could substitute for cars. So that was, I had to substitute 2 buses for 3 cars, which would make $6. So you can take that away evenly. So then I had 8 buses, 4 cars. And then I just kept following that pattern all the way down.
Okay, so can you please tell me your full solutions, your full answer?
Okay, so there's 6 total solutions. 10 buses, 1 car.
Yeah.
8 buses, 4 cars. 6 buses, 7 cars. 4 buses, 10 cars. 2 buses, 13 cars. And then just 16 cars.
Okay, so your answer is absolutely correct. That's great. So let me rephrase what Frank has told me, okay? So the only restriction you have is you have to make the total $32. So if we can establish an equation, it must look like 32 equal to the number of cars times 2, each car will charge $2, plus the number of buses times 3. Okay, this is the only restriction we have. So we have 2 variables. We don't know any of them, but we can always try out every possibility. What is the maximum number of buses we can have? Can we have 10 buses? If that is true, we have $30 buses, still below 32. Can we have 11 buses? If we have 11 buses, we would charge $33 in total, right? So, but we only have $32. So we can never have 11 buses. So the maximum number of buses is 10. So if we have 10 buses, we can have 1 car. So which makes 30 plus 2 give you 32. Can we have 9 buses? If we have 9 buses, we have $27. I use a processor to represent how much money we have from the 9 buses. How many cars do we have? Can we have? So that everything would add up to 32. So in that case, we would have $5 from the cars, but we charge $2 for the cars. So for each car, we charge $2. We can never make a $5 for the car. So this one is impossible. Can we have 8 buses? If we have 8 buses, 3 times 8 is $24. How many cars do we need to make a 32? So we need 32 minus 24, $8 from the car. So which we have 4 cars. This is correct. So we can have 8 buses, 4 cars. So you repeat the process of trying out every one. 8 bus, 7 bus. So 6 bus. So I will tell you that this one would work. This one does not work. 7 bus plus whatever car you have does not work because I tried out everyone already. 6 bus, 12 plus 12 plus how many cars? 10 cars. Oh, sorry, this is 18. 3. So it's not $10. So 32 subtract this 18 is 16. So 8 cars. Or 14. 7 cars. Apologize. This would work. 5 bus. This would not work. Just try out everything. You will see there's a repeat pattern that 4 bus, all the odd number would not work. Okay, all the odd number would not work. You will see. For this 12, this is 10 cars. 32, this would work. 3 buses. No matter how many cars you have, this one would not work. 2 bus plus 2 bus is $6.32, 26, 13 cars would work. And 1 bus would not work. 0 bus. If you have 0 bus, you get $0 from the bus, and all your money is from the cars. And each car you charge $2. So you have 16 cars. This would work. So your final answer is 10, 1, 8, 5. I'm sorry, 8, 4. 6, 7, 4, 10, 2, 13, 0, 16. Okay. So this should be your final answer. We tried everyone already. Okay, anyone has any question? There is an issue here. So we have solved this problem. Very good, we got all the credits already. However, there's a big issue. Do you guys notice that there's a pattern that if we have the even number of buses, then everything can work. If we have odd numbers, the things does not work out. Okay, I want to listen to your opinions. Does anyone have any opinion why this is true? Work does not work, work does not work. Why this is true? There's something more deep than just trying out here. And it's a little bit beyond just this question itself. Yeah, anyone want to voice his or her opinion? Okay. So if nobody want to voice his or her opinion, let me just tell you the real reason why we are alternating work and does not work here. The real reason is that we have $3 for a bus, right? So let's use B to represent the number of buses you have. We have $2 for a car. This is 3B plus 2C, and eventually we have to $32. Okay. We established such an equation. Look at this equation. If we move the 2c to the other side, you have 32 minus 2c. And there's a problem here. We can factor out a 2 here. So this is 16 minus c. If we factor out a 2, what do we notice here? This side is always an even number. Okay, just notice that this phenomenon here, this is beyond this question itself. This is telling you why this is true. Anyone has, does anyone has any question about even numbers and odd numbers? Even number is just a multiple of 2. Odd numbers are just those numbers who are not multiples of 2. So even numbers such as 2, 4, 6, 8, blah, blah, blah. Odd numbers 1, 3, 5, 7, blah, blah, blah. They are not multiples of 2. Okay, on one side, you have an even number. On the other side, you have 3 times b. So if b is still an odd number, it means it's still not a multiple of 2. If b is still odd, 3b is not a multiple of 2. Okay, I apologize. So I'm trying to write not a multiple of 2. Okay, if b is still odd, 3b is not a multiple of 2. Okay, does anyone has any question why this is true? Let's say if you have 3 times 5, 15, you cannot factor out a 2. So since 3 does not contain 2, if b does not contain 2, so 3b together still does not contain 2. So that's why you can only choose those b which contains 2 so that this equality can holds. So that 3b can equal to an even number. Okay, that's the reason why. So if you do not understand this part, that's perfectly fine. And this is beyond the question itself. We solved the question on the right side already. So this is a deep reasoning why we can only choose an even number for b. Okay, anyone has any question? Okay, assuming you do not have any question, let's proceed to example 5. Okay, example 5 is very difficult. I literally can call it difficult. Jordan and Amara ran 200-meter race. By the way, 200 meters is approximately a quarter mile. Okay, since this is an international metric, you guys might not be very familiar. Just approximately a quarter mile. And Jordan wins by 10 meters. They decide to run 200-meter race again, with Jordan starting 10 meters behind the starting line. Assume both runners run at the same pace as they did in the first race. Who would win? Again, I will draw a graph to help to facilitate your thinking, and I'll give you a few minutes to think on your own. So this is round 1. Round 1. They are running 200 meters. This is Jordan. This is a race track for Jordan. This is a race track for Amory. Okay. So when Jordan reaches the ending, Amory 10 meters behind, so which is here. So Jordan actually just run 190 meters, right? When Jordan reaches here. So when Jordan reaches here, Amory is still 190. So you can denote Jordan's speed by V1. Similarly, you can denote Amory's speed by V2. Okay, so you can have some kind of relationship between V1 and V2. And I give you 3 minutes to think about it. Okay, so this question is very difficult, but I give you plenty of hints already. So just follow my ideas. What's the relationship between V1 and V2? So 3 minutes to think about it. Okay, 3 minutes is over. So anyone has any kind of ideas or opinions on this question? Does anyone figure out this question already?
Yeah, I believe they finish at the same time.
Okay, that's a good opinion, but I disagree with you. Okay, so let me give you why I think Jordan is still faster. Okay. So first time you're running 200 meters, right? when Jordan finished his racing 200 meters, Amory only went run 190 meters. For the same time, same amount of time, so Jordan run 200 meters, Amory run 190 meters. So in other words, so let's say the time for them to finish is T. So Jordan's speed is V1. Speed times time is distance run, give you 200 for the first round. And V2 times 70 give you 190. Okay, so starting from here, we can find a relationship between V1 and V2. So V1 divided by V2 is 200 divided by 190. You just divide this by this, so all the t cancel out. That's why you have V1 over V2. This side divided by this side, 200 divided by 190. You have such a relationship, right? Anyone has any question? Okay, anyone cast any doubt on this equation? Okay, so we draw a graph to represent the what's happening in the round 2. This time, Jordan, he is running 210. Okay, Amory, he is running 200, still running 200 track. Apologize, 210. 200, so it should be need to be shorter. Okay, so Amory is running 200s, but Jordan is running 210. So who would finish earlier? In other words, who would use less time to finish running? So how much time does it take Jordan to finish? So for Jordan, is 200 the distance divided by the speed. For Amory, is 200 divided by its speed, his or her speed, right? Any question about the time? Time to finish round 2, Jordan, distance divided by speed. So we are curious which one is bigger, which person spend more time running. We do not know, but we can do one thing. If this number divided by this number is greater than 1, it means Jordan spent more time. If this number divided by this number is smaller than 1, it means Jordan spent less time. Do you guys agree? Okay, so we need to find a relationship between (210) divided by 200 over 2. Okay, this is dividing line. Slash means dividing line. We need to find a relationship. If it is greater than 0 or greater than 1, sorry, or smaller than 1 or equal to 1. So we want to figure out whether this guy is greater or smaller or equal to 1. Okay. Then we can simplify this fraction. So if you do such a division, what do you get? So you get 210 over V1, 200 over V2 which is 210 over 200 V2 V1. Okay, so here's a tricky thing. We find that V1 over V2 is 200 over 190. So what is V2 over V1? V2 over V1 is just reverse the fraction you have, which is just 190 over 200, right? That's it. Are you guys following me? Do you guys know why I'm getting here and here? Any question?
I don't understand how you got that.
Okay. So do you agree with this?
Yes.
So what is V2 over V1? Is it 190 over 200? Do you agree?
Yes.
Okay, I'm just reversing the fraction. I'm not doing something
Okay.
bad.
I
Okay,
got you.
okay. So once you get to here, since V2 over V1, you can separate the fraction. So it's 190 over 200. Great. Thank you for asking. Anyone has more question? Okay, so if you plug into your calculator, anyone do me a favor? Plug this fraction into the calculator. See whether it's greater than 1 or smaller than 1. Anyone do me a favor on this?
Okay, so it's 1.05, I guess.
Okay, you said it's 1.05. Does everybody get the same answer as he?
I got 0.9975.
Okay, so I think the lady is right. Yeah. So this is should be somewhere around 0.9975, which is
Okay, yeah,
more
yeah,
than 1. So what does that mean? This is Jordan's time. This is Amory's time. So if you divide Jordan's time by Amory's time, it's smaller than 1. So which means Jordan still spend less time than Amory. Okay. I have to use a space from the second question. So Jordan spends less time than Amory. That's the whole point. So Jordan still wins. Any question on the first one? Okay, so let's continue to part B. How far behind the start line must Jordan start? So the second race is a tie. By saying the second race is tie, I mean they run the same time. So the same time, which means 200, not 210. So what's the time for the second race? Jordan is starting behind. So let's say Jordan is starting behind at the red C. Previously, C was 10. Okay, Jordan was 10 meters behind. That's why he ran 210. But right now, he ran 200 plus C. He still uses the same speed. And Amory still ran 200 meters. He still runs at the speed V2. In other words, a tie means they are still running the same time. Okay, same time. So if we get such a fraction, we should do some manipulation to figure out the number C. However, V1 is unknown, V2 is unknown, but V1 over V2, this ratio is known. So we can try to get rid of V1 and V2 together by building such a ratio. There's one thing you can do. You can switch 200 with V1, okay? That's just a very common fraction operation. So let me be a little bit more detailed. You can divide both sides by 200s. So 200s go to this bottom. Then you can multiply both sides with V1. Okay. Divide both sides by 200, we get put 200 here. 1 is here. Multiply both sides with V1. We get rid of V1 in the bottom, have the V1 in the upper part. So we successfully create a V1 over V2 shape, which is 200 over 190. So once you get from here to here, only C is unknown. What can we do with C? Again, we can try to isolate C. We can multiply both sides with 200s. So 200s plus C equal to 200s times 200s over 190. Just multiply both sides with 200s. So then you can subtract both sides with 200s. 200s equal to 200s over 190 minus 200s. Okay. Can anyone do me a favor? Use a calculator to figure out what is this number? What is CC? Yeah, do me a favor, please.
$10.52.
Very good, thank you. Okay. So in other words, Jordan should stay 10 meters, 10.52 meters behind the line, so that they arrive at the end approximately with the same time. Okay. So this is time by Jordan. I just need add a little bit of notes here. This is time by Amory. Okay. Anyone has any question on the part B? Example 6. So example 6. A small grill can cook 2 hamburger patties at one time. If each hamburger patties need to be cooked for 5 minutes on each side, what is the shortest amount of time it will take to cook 3 hamburgers? So we do not have enough time to finish all the explanation of the example 2, but let me give you a hint. Just try it. You can try it at home, try it in your kitchen, see how things are going, okay? So we are approaching the end of the class, and this question should be easy. Just try it. So we will talk it at the beginning of the next class on Thursday. Okay, just do not overthink about it, just try it out. Okay, so we are just 1 minute away from the end of the class. Let me take the attendance. Okay, I'm done with the attendance. And the time is right now 6:15. Great timing. So feel free to go, stay here if you have any questions. Okay, see you guys on Thursday.
Bye.
Bye.
Thank you.
You're welcome. Bye, have a
Bye,
good one.
thanks.
Great. Remember to try.
Hello. I'm
Hi,
actually not
Jasmine.
enrolled in this class yet. I sent you an email earlier asking
Oh, yeah.
if you could
Oh, I
give me
see your
permission
email.
to class.
I see your email. Let me put my signature on the form right now. Is that okay?
Okay.
Do you have other questions?
Yes. Have any assignments been due since
Yeah, so
class
every
started?
week we have some assignments.
Okay.
Every week we have some assignments in the My Math Lab. So if you read the syllabus, you should be able to see the My Math Lab. Please make sure you re-enroll it as early as possible.
Okay. So, are those assignments still accessible to complete
Yes.
now? Okay,
They
thank you.
should be accessible.
So I can catch up on all the assignments I haven't been able to complete.
Yes, but
so far?
there is a penalty for being late, which is 20%
Okay.
credits off. But everybody get a free. Since for the first week, you can be late. Since we are just beginning the semester, you might not be familiar with how the My Math Lab works. So
Okay.
that's how people can get free for the first week. But after the first week, for the second week, so there will be penalty, 20% penalty there.
Okay, but I can still do the assignment.
You can still, and you're very welcome to do. You're required to do that.
Okay. And are there class recordings available so I can look
Yes,
back
please.
over the lessons?
After I return this signed form to you,
Mhm.
and you submit it, you should be able to log into the Canvas,
Okay.
and you will see the past recording of this class. And
Okay.
feel free to ask me any questions if you have.
Okay. Thank you.
Yeah, by now we are learning something easy. So I would recommend you do not overthink what we are learning. Just take it easy. We're learning something easy, okay?
Okay. Thank you very much.
You are most welcome. Anything else I can help you?
No, that's it. As soon as
Okay.
I receive the form with your signature, I'll send it to the office so I can get enrolled in class as soon as possible.
Okay, great. So let me remind you, please read the syllabus.
Okay.
Yes, to see what are the requirements and expectations of this class, okay?
Okay, thank you.
Okay, thank you, Jasmine, goodbye.
Thank you very much. Oh, how should I call you? Should I call you Mr. Lu?
Yes, that's perfect.
Okay, thank you, Mr. Lu.
Okay, thank you, bye.